Hello, so we're into Unit 16, and there are going to be two topics of the video lectures. I'll be talking about an issue that arises in doing derivations, which I call cycling, and I'll be continuing the discussion of models. And I may talk about, and I'll talk about complex only a little bit, so three topics actually. Forgot one. Okay, so we're going to start with this. The first two videos will be about this derivation issue. So we're going to start by actually looking at a derivation where the derivation issue arises. Okay, so here we have a pretty straightforward derivation. We don't need to make an assumption in this case. But we want to show some x fx. Now, so we can instantiate 2, which is an existential quantifier. Now at this point we have fi, right, already. And from fi, as you know, we can do eg. The problem, though, is that we have to get it outside of this conjunction, and to get it outside of the conjunction we have to instantiate the universal quantifier. So we'll say 3ui to, well, we can do it to I. It doesn't actually matter what we ui this to. Let's go to t, for example. And now we get we simplify out the fi, and we instantiate, or generalize, and that's our derivation. So this is a pretty straightforward derivation. What it illustrates is that sometimes you have to use instantiate a quantifier, not because you are going to use it, but because you have to use it to get at something you already want. And that's a problem that we're going to see arise, and it's going to be more troublesome in other derivations. The fundamental problem is sometimes a quantifier is in your way for you to get to something. Okay, so let's look at another problem, another derivation where this issue arises. Okay, so show the conclusion. And again, we're not going to need to make an assumption. Let's just look at the two premises. So if we look at these two premises, so we're doing universal, we're trying to show universal. So what we want a universal quantification. So we're going to aim to do a universal derivation. So what we want to get is, in the end, we're going to get hx, and we're going to say universal derivation. That's how we're going to finish it. Okay, fine. And if we look at 4, we see, well, if we can get the antecedent, something is f, then we can get the consequent. And if something is f, then this tells us that that thing that's f then we know that every f is h. And so if we can get that x is f, and we can get that something is f, then if we can get that x, if we get fx, then we can eg. And that'll put those together, and then we can say ui to x with for all x if fx and hx, and we'll do 6, 9 modus ponens, and that would be the universal derivation, right? So it looks like, given premise 2 or line 4, that's how the derivation is going to end. So we want to see if we can get for all x fx. And if we look at line 2, indeed we can get, if we instantiate, the universal binds the x and the fx, and the existential binds the some y, the y and the gy, so we can instantiate, and so we get fx from line 2. And note here, this time this is the excess quantification. Actually, I shouldn't have done that in one line. So let's here. So here again we have the fx, and we want to get it, but we have to instantiate line 4 first, right? Now, so then we go ahead and simplify left. That's fine. We can essentially generalize this back, and then we'd say modus ponens. Now here, you might think, look, at this point, we know that we can instantiate to x, right? And we're going to be done. But if we weren't really paying attention and thinking about how the derivation is going to go, we think, well, when we have a universal quantifier, we're supposed to instantiate it to everything. So we should instantiate that to I. And in fact, let's go back to here. So here we get fx and gi. We think, oh, well, there's a new variable. which we got from EI. And we're supposed to instantiate every quantifier, every universal quantifier to everything we get from EI. So we better instantiate this universal quantifier in line 2 to I. Think, well, if we're going to use this line 6, we're going to need to instantiate that exponential quantifier. Oh, look, there's a new variable from existential instantiation. Well, we're supposed to instantiate every universal quantifier to every variable we get from EI, so we better instantiate line 2 to j. And well, if we're going to use line 8, we need to get rid of that existential quantifier. And, oh, look, there's a new variable from EI. Well, we better instantiate line 2 to it, because we need to instantiate our universal quantifier to everything we get from EI. And since if we're going to use line 10, then we need to clear off that existential quantifier, so it's going to have to be a new variable. So you can see that this cycle will never end, right? It doesn't need to end. In fact, we don't need to do any of this. Let's see. We don't need that. And this is line 6. Right? We don't need any of those things. So, but in noticing that, or in pursuing this strategy, in completing this derivation, when we go from line, when we go from 5, at 5 we have two options. What we did was we did SL, right? And that's the good thing to do. And I'm glad we did SL. That was smart. But what the strategic instructions would have us do, they would tell us to go back and instantiate 2 to I. And at this point, the instructions are actually kind of silent as to what we should do. Well, they're not. They say you should instantiate every existential quantifier. So the basic strategy instructions would have us instantiate again, and we're never going to end. So in the presence of a for every x sum y, the instructions, our strategic instructions, will get us into a never-ending loop. And it's not a good never-ending story. It's a never-ending cycle that never ends and just goes and goes and goes forever. Because on one hand, we're supposed to instantiate universal quantifiers to anything we get from EI. And on the other hand, whenever we get an existential quantifier, we're supposed to instantiate it. And so that means, well, okay, we get this GJ, we better instantiate line 2 again, and then we have to instantiate an existential quantifier again, we get a new variable, and so on. So the strategic instructions break down in the presence of for every x sum y. And that's a problem. We're going to need to figure out, well, how do we revise our strategy to take account for that? So we're going to and handle the problem that it generates. So we're going to talk about that for a little bit. So let's pop back over to Keynote. Let me see. So where do I want to start, actually? Because I've talked about what's in some of these slides already. Yeah. So the problem is that in one of these derivations, you cannot both universally instantiate each quantifier to each free variable and instantiate each existential quantifier and get a set of well, you can't UI each universal quantifier to each free variable and at the same time get your contradictory quantifier free sentences. If you remember a few units back, I talked about the strategy, and the idea of the strategy is you do EI and UI in the right way. You instantiate each existential quantifier, universally instantiate each universal quantifier to all those variables from EI and to names, and then you get a set of sentences that are quantifier free and contradictory. But you can't follow that strategy anymore. You can't UI to each free variable and generate a set of contradictory quantifier free sentences. So we have to do something else. So and this sort of describes this problem. The problem comes from the for every x sum y structure, which is what generates that problem. So one idea would be to be a little bit subtler about our instantiation. So we want to still get to quantifier-free quantifier-free sentences that are inconsistent and from which we can extract a contradiction. What we need to do then is recognize two different kinds of EI and then restrict our UI appropriately. we're going to do some EI we do because we want to instantiate the existential quantifier, because we want to be able to talking about a particular object. And that's what happens here. Actually, we don't even need this existential quantifier in this case. So this existential quantifier, we don't instantiate it, as it turns out, because we care about GI. We don't care about GI at all. GI is never used down here. We only instantiate this quantifier in the end to clear off, to get it away so we can get at the fx here. So we can do simplification on the conjunction. The idea is that we want to distinguish between desired EI and undesired EI. Desired EI is, I actually want to work with that instance of the existential quantification. Undesired EI is, I don't care about that instance of the existential quantification. I'm only doing EI to get rid of the existential quantifier. So you UI to free variables if they're from desired EI. You don't UI to free variables from EI if the EI was just made in order to eliminate quantifiers, as it is in the derivation we just saw. The problem, what's hard with this strategy is that you have to keep track of which stage you are at in a cycle. You need to know, when you do an EI, am I doing this because I want to and I care about the instance, or am I doing this just in order to clear off the existential quantifier? I'm not, and it can be hard to tell. So that's a tricky issue with the strategy. And so in the next video, I'm going to talk about some other strategies that we can use to deal with these with these quantifier structures where there's cycling, and we have trouble sort of telling which variables we want to work with.